Today we're going to draw the Lewis diagram and the geometry for hydrogen carbonate, as well as finding their hybridization and bonding scheme, which is pi and sigma overlaps. So what I've got here is a ready-to-go Lewis structure. To do that, I checked for the octet rule. I looked for formal charges, which determined that you can have two resonance structures. This is the first one, and the second one is bonded with this oxygen, but not this oxygen, because formal charges say this oxygen already has a zero charge, while this one has 1, this one has 0, this one has 0. So check the formal charge, and then after that, we're going to jump into drawing our geometry. So there are several central atoms. So what we need to do is look at one central atom that we're going to start with. Oxygen has AX2. The X2 is the surrounding atoms, and there are two lone pairs. So that means we have one shape there, which is going to be a tetrahedral electron group arrangement, but it's going to be bent. Okay. Bent, and their angle is going to be just less than 109.5. So carbon here has AX3 atoms around it, no lone pairs, so it's going to be a trigonal planar shape with ideal bond angles of 120. So sometimes double bonds will affect the bond angle, but that is more particularly for carbon-hydrogen bonds. So in this case, we don't need to worry about that. Trigonal planar has an ideal bond angle of 120, and this bent shape will be a little bit less than the ideal bond angle of its electron group arrangement, which is 109.5. Okay, now what is the hybridization for each of these atoms? So hydrogen will not have a hybrid orbital, it's just one s orbital to bond. Oxygen here, as we have determined X2E2, so that means we need 4 atomic orbitals. We need 4 hybrid orbitals, so we're going to borrow 1 from S, we're going to borrow 3 from P, which will give us 4 hybrid orbitals. Now carbon has AX3, that means we need 3 orbitals to mix 3 hybrid orbitals. So that will give us sp2, because 1s plus 2p, 1 plus 2 makes 3. Now this oxygen, of whose lone pairs I need to add. This oxygen has, what is it? Let's see. It has AX1 and the E3. For 4, we need 4 hybrid orbitals. S1 plus P3, 1 plus 3 makes 4. And this oxygen, because it has a double bond, it's a little different from the other oxygen. This one has AX1E2, so 3, we need 3 hybrid orbitals, sp2. 1s plus 2p, 1 plus 2, that's 3 orbitals, hybrid orbitals. Now that we have their hybrid orbitals, we can finally determine what will be their bonding scheme. So oxygen and hydrogen. Oxygen will use its sp3 to bond with hydrogen's 1s orbital, and any single bond will give you a sigma overlap, okay, sigma overlap. And it will also be a sigma overlap between oxygen and carbon. You see, we're just copying out the hybrid orbitals, which is the orbitals they use to bond. Now, between carbon and the singly bonded oxygen, it is also a sigma overlap, because you see there's a single bond, then you say there is a sigma bond. We just copy it out. It's going to use its hybrid orbital to bond with the other one's hybrid orbital. Now, the double bond is more different. So we're just going to make a note here, double bond. That means whenever you have a double bond, you're going to say there is one sigma bond and one pi bond that makes it up. So the sigma bond is just going to be its regular hybrid orbital binding with another one's regular hybrid orbital. Now be careful how You see that there are two oxygens, but they have different hybridizations. Make sure you write the hybridization that is for the double bonded oxygen. Okay, now for the pi bond. Pi bonds are made up of two unhybridized orbitals. Unhybridized orbitals. That means there is no sp. There is no sp2. There is nothing that deals with s and p. It has to be either s, it has to be either p, it has to be a single orbital and not a hybrid orbital. So that means both of what we're going to insert in these brackets are only going to be just your regular valence electron orbital, which is 2p for carbon, because it's valence electrons in 2p. And oxygen, same thing, 2p. And there you have it.